In the previous lecture, we learned the unit circle. We learned how to convert an angle from degrees to radians, and from radians to degrees. The angle we are talking about is also the angle between the initial edge and the terminal edge. And note that the terminal edge intersects with the unit circle at one point, and the coordinates of this intersection point also tell us the values of sine function and cosine function, and we'll talk about that in this lecture. So let's start with the definition of trigonometric functions using a right triangle. Here I have a right triangle, and I'm going to define this angle, theta. And I'm going to call the edge that is opposite to this angle the opposite side, and the other side that is next to the angle, which forms a right angle with the opposite side, the adjacent side, and the last side, which is the longest side, the hypotenuse. So as I mentioned in the previous lecture, there are 6 trigonometric functions. There is the sine theta, cosine theta, and tangent theta. And there's the cosecant theta, secant theta, and cotangent theta. So all these 6 functions are defined as the ratio of the sides on the right triangle. The sine theta, it is the opposite side divided by hypotenuse. And cosine is adjacent divided by hypotenuse. And tangent theta, which also equals to sine theta divided by cosine theta. And its ratio using the sides of the triangle, it would be opposite divided by adjacent. And the other 3 functions on the right, they are the reciprocal of the 3 functions on the left. Cosecant theta, it is 1 over sine theta, so its ratio would be hypotenuse divided by opposite. And secant theta, it is 1 over cosine theta. So its ratio is hypotenuse divided by adjacent. And lastly, cotangent theta, it is 1 over tangent theta, which also equals to cosine theta divided by sine theta. And its ratio is adjacent divided by opposite. There is a quick way to remember this. If you can remember SOHCAHTOA. SOHCAHTOA is SOH, CAH, and TOA. SOHCAHTOA. SOHCAHTOA means a sine function is opposite divided by hypotenuse. A cosine function is adjacent divided by hypotenuse. And the tangent function is opposite divided by adjacent. So you can remember this, SOHCAHTOA. Then you can remember all these 6 trigonometric functions. Let's look at these 2 examples. So I have 2 right triangles and the sides are given. We want to write out the ratios of sine, cosine, and tangent theta. The first one, the opposite side has length 3. Adjacent is 4. And hypotenuse is 5. So, sine theta, which is opposite divided by hypotenuse, it would be 3 over 5. And cosine theta, it would be adjacent divided by hypotenuse, so its ratio is 4 over 5. And lastly, tangent theta, its ratio is opposite divided by adjacent, so tangent theta equals to 3 over 4. How about the second triangle? The opposite side is y, the adjacent is x, and the hypotenuse is 1. So, sine theta, it would be opposite divided by hypotenuse. And cosine theta, it would be x, the adjacent, divided by the hypotenuse, 1. And the last one, tangent theta, it would be opposite, which is y, divided by the adjacent x. Now I want you to relate this triangle to the unit circle. So since the unit circle has radius of 1, so the hypotenuse of this triangle corresponds to the radius of the unit circle. And let's take this side as the positive x-axis. So this will be our initial edge, and this will be the final edge. And this is our angle theta. And since this side has length of 1, which corresponds to the radius of our unit circle, which means this point would be the intersection point of the terminal edge and the unit circle. So on the Cartesian plane, this point has coordinate of x and y. And the x of the coordinate is also this length, since the unit circle is in standard position, so this point is the origin. So this length would be the x coordinate for this point. Similarly for this side, this height would be the y coordinate of this point. So how we just found, sine theta would correspond to the y coordinate of this point, and cosine theta corresponds to the x coordinate of this point. So here's a summary of how we can use the coordinates on the unit circle to find the 6 trigonometric functions. So as we just found, the y coordinate of the unit circle corresponds to sine theta, where theta is this angle here, from the initial edge to the terminal edge. And the coordinates of this point correspond to cosine theta. And since we can write the other 4 trigonometric functions in terms of sine and cosine, tangent theta is sine divided by cosine, so this value would be the y coordinate divided by x coordinate. And cosecant theta is 1 over sine theta, so it would be 1 over the y coordinate of the point. Secant theta is 1 over cosine, so it would be 1 over the x coordinate. And cotangent theta is 1 over tangent theta, so it would be the x coordinate divided by the y coordinate. And just a quick note on the notation. We write the square of sine theta as sine, and we put the square in between sine and the theta. This is a unit circle with all the coordinates labeled. So the initial edge is lying on the positive x direction. So if the terminal edge is also here, then that is 0 degrees or 0 radians. And this point is when x equals to 1 and y equals to 0, since the radius of this circle is 1. So it has coordinate of 1 and 0, which means cosine of 0 equals to 1 and sine of 0 equals to 0. This plot also shows all the x and the y coordinates at different angles. There are 30 degrees, 40 degrees, 60 degrees, and the corresponding angles in the other 3 quadrants. So if we know the coordinates, then we can find the cosine and the sine of this angle. Let's look at pi over 3 radians. This point has coordinates of 1 over 2 and square root of 3 divided by 2, which means cosine of pi over 3 equals to 1 over 2, and sine of pi over 3 equals to square root of 3 divided by 2. So if you can memorize this circle, then you can find the trigonometric functions evaluated at these important angles. You'll also find a copy of this unit circle at the beginning of this section, in lecture 36. And here are some basic trigonometric identities. They are the Pythagorean identities. You can derive them using the ratios of the trigonometric functions. For example, the first one, sine squared plus cosine squared equals to 1. Sine squared is opposite divided by hypotenuse, and cosine theta is adjacent divided by hypotenuse. So if we take the square of them and add them up, then we have opposite square plus adjacent square divided by hypotenuse square. And using the Pythagorean theorem, adjacent square plus opposite square equals to hypotenuse square. So this ratio equals to 1. Similarly, you can prove the other 2 theorems using Pythagorean theorem. So we have tangent square plus 1 equals to secant square. And 1 plus cotangent square equals to cosecant square. Then there's the even and odd identities. We talk about the definition of even and odd functions in section 3. For an even function, when we put a negative of x into the function, then the output would be the same as if we put x into the function. And an odd function is when we put negative x into the function and we get negative of f of x. And since sine theta corresponds to y-coordinates of the unit circle, so if we compare the y-coordinates of a positive theta to negative theta, you can see from the unit circle that they are symmetry, but the y values goes from positive to negative. So a sine function is an odd function. When we put negative theta into the function, we get negative of sine theta. On the other hand, the cosine function is an even function. Cosine function corresponds to the x-coordinate. So when we have a positive angle, it will have the same x-coordinate as if we have negative theta. So cosine of negative theta equals to cosine theta. And tangent theta, which is sine divided by cosine. So sine of negative theta would equals to negative of sine theta divided by cosine theta, which is negative of tangent theta. So tangent theta is also an odd function. Then we have the shift identities. If you observe from the unit circle, you'll note that the x and the y coordinates, they are shifted by 90 degrees by pi over 2 radians. Cosine of theta minus pi over 2 equals to sine theta. And sine of theta plus pi over 2 equals to cosine theta. And remember from the previous lecture, we mentioned that an angle could go around the unit circle more than once. But since the terminal edge would be aligned if we go more than once, so sine of theta plus 2 pi would be the same y-coordinate that would equals to sine theta. Similarly for cosine, cosine of theta plus 2 pi equals to cosine. And we can even go twice around the circle. Sine of theta plus 4 pi also equals to sine theta. Then below there are a few more identities that you'll need to memorize. There's the sum identities. When we have a sine or cosine function, and inside we have a sum of two angles, we can rewrite them in this form. Similarly, there's the difference identities. So if we have sine or cosine of difference of two angles, we can use the identities here. Below there are a few more identities, double angle identities. When we have sine and cosine of 2 times theta, we can rewrite them as this form, or an alternative form. Or with some rearrangement, I can isolate for the sine square and the cosine square, so I can rewrite the sine square and cosine square in this form. This figure shows the graphs of trigonometric functions without doing any transformations. So I plot the x-axis as the angle. From 0 to 2 pi, it will represent one circle, and the y values correspond to the trigonometric functions. The first one is sine theta. So sine theta is also the y-coordinate on the unit circle. When angle equals to 0, the y-coordinate is 0. So it starts from 0, then it increases, and it reaches to 1 when angle equals to pi over 2. That is 90 degrees. Then it will decreases, reach to 0 at pi, then it goes down again to negative 1, and the y-coordinate goes back to 0 at 2 pi, and we complete one round of the unit circle. So you can note that a sine function is a periodic function, and it has a period of 2 pi. From 0 to 2 pi, it goes around like this. Then from 2 pi to 4 pi, it will be the same form, the same wave again. And the second panel shows the graph of cosine function. So a cosine function corresponds to the x-coordinate on the unit circle. So at 0 angle, the x is 1, since the radius of the circle is 1. So a cosine function will start from 1, then it decreases until negative 1, that is when angle equals to pi, or 180 degrees. The x-coordinate is negative 1. Then the x-coordinate goes from negative 1 back to 1 when we complete one cycle of the unit circle. So a cosine function also has a period of 2 pi. From 0 to 2 pi, the function goes from 1 to negative 1, then back to 1. And we get the same shape from 2 pi to 4 pi, or from negative 2 pi to 0. Then the third panel, we have a graph for tangent function. Since tangent function is sine divided by cosine, and we can never have a zero in the denominator. So the graph for tangent function, we see a vertical asymptote whenever cosine function equals to 0. That is when x equals to pi over 2, 3 pi over 2, 5 pi over 2. So here's how the tangent function looks like. Similarly with the other three functions, since they are all reciprocal of the other three functions, so whenever the first three functions equals to 0, we have a vertical asymptote for the lower three trigonometric functions. And that is the end of the lecture. In this lecture, we learned how to use the coordinates on the unit circle to find the values of a trigonometric function. And we found that all the trigonometric functions are periodic, which means the trigonometric functions are not one-to-one. But we can still define a restricted domain so that the functions are one-to-one. Then we can find the inverse of the functions over the restricted domain. Let's talk about the inverse trigonometric functions in the next lecture.